Hello everyone, and welcome. Today, we're diving into the fascinating world of coordination chemistry. We're going to talk about something called a ligand. Specifically, we'll be answering the question, what is a bidentate ligand? First, let's quickly understand what a ligand is. Think of a central metal atom or ion. A ligand is simply a molecule or ion that binds to that central metal. It does this by donating a pair of electrons to form a coordinate bond. You can imagine the metal as a central hub, and the ligands are the things that attach to it. Now, ligands are classified based on how many times they can attach to the metal. This is called their denticity, which comes from the Latin word for tooth. So, we're basically asking how many bites a ligand can take out of the metal ion. The simplest type is a monodentate ligand. Mono means one. So, a monodentate ligand has only one donor atom and can form only one bond with the central metal. Think of molecules like water or ammonia. They each have one atom that can donate an electron pair, so they take just one bite. This brings us to our main topic, bidentate ligands. As you might guess, bi means two. Therefore, a bidentate ligand is a single molecule or ion that has two donor atoms. This means it can grab onto the central metal ion at two different points at the same time. When a bidentate ligand binds to a metal, it forms a ring-like structure. This special ring is called a chelate ring. The word chelate comes from the Greek word for claw, because the ligand looks like it's grabbing the metal with a claw. Let's look at some classic examples. A very common bidentate ligand is ethylenediamine, often abbreviated as N. Its structure has two nitrogen atoms, and each nitrogen has a lone pair of electrons it can donate. So, it attaches to the metal using both of its nitrogen hands. Another great example is the oxalate ion. It has two oxygen atoms that can each donate a pair of electrons to the metal, forming a stable ring. So why does this matter? Complexes formed with bidentate ligands are much more stable than similar complexes formed with monodentate ligands. This is known as the chelate effect. Think about it like this. It's much harder to lose something you're holding with two hands than with just one. The bidentate ligand has a much stronger grip on the metal ion. This extra stability is incredibly useful in many areas, from removing toxic heavy metals from the body in chelation therapy to applications in industrial catalysis. So, to quickly recap, a ligand donates electrons to a central metal. A bidentate ligand has two donor atoms, allowing it to bind at 2 points and form a stable chelate ring. This leads to the chelate effect, making the whole complex more stable. Thank you so much for watching. If you found this video helpful and learned something new, please hit that like button and consider subscribing to the channel for more chemistry tutorials. Don't forget to ring the notification bell to stay updated. Your support truly helps us continue making educational content. We'll see you in the next video.